In this section, we're going to look at exponentials and logarithms of other bases other than e. We're going to learn new differential rules and combine them with all of the rules that we've learned previously. Take a moment to pause the video and make sure that you have all of your log rules written down. You learned these originally in Algebra 2. We use them again in pre-calculus, and they are incredibly important for simplifying our equations so that we can derive them. Just like in the previous section where you were reviewing your graphs of e to the x, you are also going to have to review your graphs of logarithms. And so we need to remember that they are inverses of one another, and therefore logarithms have a vertical asymptote coming up the y-axis. The point that exponentials cross at, 0, 1, becomes an inverse point. Remember, x's become your y's become your x's, and therefore our crossing point is going to be 1, 0. So the graph follows the asymptote and then sees that point, and that's what causes it to curve off. Okay, so now let's look at a graph who has transformations occurring. So all of your transformation rules hold. The negative is an x-axis reflection. Remember the pattern that this should be x minus h, therefore you have a negative 2, which means it's going to shift left 2. And then the positive 3 is shifting up 3. So the first thing that I'm going to do is take my shifting point that was 1, 0, and I'm going to have it shift left 2 units, so that goes to negative 1, and then up 3, so negative 1, 3. And then my asymptote is also shifting left 2 units, so it was at 0, it's now at negative 2. And it's reflected, so my graph is coming down the asymptote, sees the turning point, and curves off. Okay, so your derivative rules for bases other than e. You have a basic exponential, a to the x, and then when your exponent changes from anything from 1x to the first power, that becomes an a to the u, including the chain rule. So remember, your derivative u prime multiplies the original derivative of the a to the exponent. And then you also have a rule for log base a of x and a log base a of u. Again, the log base a of u is incorporating the chain rule. So make sure you write these down. As we go through this, I'm going to show you how to make sure that you keep organized. It's important that you know your rules and that you know the pieces of the rules. Okay, so let's get started. Our first derivative is going to be deriving g of x equals 2 to the negative x. On this type of function, I like to stay organized. So I'm going to identify a. A is my base, it's 2. My u is my exponent, negative x. And when I derive u, I get u prime. And deriving the negative x, I get negative 1. And so I can follow my pattern. I know that my g prime of x is going to be u prime, which is that negative 1. So there's my negative. A to the u, so the original problem, 2 to the negative x, and then ln of a. So ln of a, which was 2. And that is the final derivative. So on this one, we need to really stay organized. We can tell we have a product right here. The 5 negative alpha over 2 is my f, and the sine 2 alpha is my g. So in addition to my a to the u rule, I'm also going to be following the product rule that we learned back in section 2.3. So f prime g plus f g prime. That's the basic pattern I'm going to be following. So to derive f, I need to know a is 5, u is negative alpha over 2. Now, because we're putting in the Greek letters, sometimes students get a little confused about those, but those are just like x's. There's no difference if I had written negative x over 2, or even a better way to see it in your mind, negative 1/2 of x, because we know that derives to negative 1/2. So u prime, negative 1/2, because that alpha is to the power of 1. Okay, so following my pattern, my g prime of alpha is equal to u prime, which is my negative 1/2, a to the u, keeping my original exponential prior, 5 to the negative alpha over 2, and then ln of a. So I have ln of 5. Now, all of that is f prime. Now I'm ready to multiply by g, because I just simply keep g, and then the product rule says add, keep f, 5 to the negative alpha over 2, and derive g. So sine derives to cosine, keep your angle pure, and remember the derivative of 2 alpha, we're just going to put that right in front, 2 times 5. And there is absolutely nothing I can do to clean this up. It is just the way it is, and we're going to leave it. It's beautiful, isn't it? Okay, so now on to logs. Same thing, you want to make sure that you know what a is, and that you know what u is, and that you know what u prime is. Keep all of your pieces organized. But we also want to make this simpler on ourselves. So before I do any deriving, I'm going to use my log properties and break this apart. So I know that on top I've got 2 things that are multiplying, so I'm going to add 2 logs right there. This 1/2 is going to drop in front of this log when I write it, and then the 2 will be a log that subtracts at the end. So the way that this expands looks like this. I have log base 3 of x plus 1/2, that's my square root, log base 3 of x minus 1 minus, and here comes my denominator, log base 3 of 2. Okay, so when I'm looking at this first one, it's not an AU. It's just simply an x. So the derivative of x is 1. So this one derives with the basic pattern of 1 over whatever's inside your log times the ln of your base, ln 3. Okay, then I move on and I say plus. The 1/2 sits and waits for me, and this one is an a to the u. So a is 3, u is x minus 1, and u prime is just 1. So again, I have 1 over u was x minus 1, keep it in parentheses, and then ln of a, which is ln of 3, minus log base 3 of 2. This is just a number. How do numbers derive? To 0. So it's gone. So I'm just looking at the first 2, and I'm going to make a common denominator. So they both have the ln 3, and this first one has an x that the other one doesn't have. So I'm going to switch colors real quick so you can see what I'm adding. So this one needs the x minus 1, and it needs the 2. And so what I give to the bottom, I give to the top. Okay, the one on the right needs just the x. So what I give to the bottom, I give to the top. And as I clean this up, do you notice that I could write this as 2 ln 3, and that 2 could pop up, and that could be ln 9. So I'm going to make that change as I rewrite the problem as well. Okay. So getting busy, I have h prime of x is equal to, and I'm distributing my 2x minus 2 plus x all over x minus 1 ln 9. Simplifying it just a little bit better, h prime of x is equal to 2x plus x, 3x minus 2, x minus 1 ln 9. Not difficult, just keep it organized and you'll be fine. That's your final answer. Okay, so now this is your turn. What lesson would be complete without a quotient rule? So make sure you know all your rules, keep all of your pieces organized, and you're going to be just fine. When you get to problems 57 through 60 in the homework, you're going to notice that they look very different. You are given a rule for a to the u, where a is a constant. But do you notice when we look at this problem, we have a variable x carried to a power of x minus 1. We don't have a derivative rule for that. But we do have an algebra rule for that. Logs were built to bring down untouchable exponents down to the baseline. So if I ln both sides, this cute little x minus 1 gets to drop right down in front. Now it's no longer an untouchable exponent, it's a very derivable product rule. So I also have the implicit rule embedded in this as well, because now y isn't just sitting there as y equals. So deriving ln y, it's the ln rule, 1 over y, but because we touched a y, y prime. Now I'm going to do my product f, which is x minus 1, so f prime is just 1, and I keep g, ln x, plus keep f, x minus 1, and derive g. ln x is the 1 over x, so 1 over x, I can just put the x in the denominator. Final steps is just cleaning it up. So I want a common denominator, so I have x times ln x plus x minus 1 all over x. My y, 1 over y, y prime, is equal to that. And I'm going to bring my y over to remove it. However, remember, we know what y equals in terms of x. So I'm also going to substitute that in, but I'm going to put it in front. X minus 1, that's y. And then my x, ln x, plus x minus 1, all over x. And I know there's a ton of x's here, but none of them cancel, so no illegal algebra canceling. And leave your answer just like this. It's gorgeous. So this is your final question. It's just like the one I just did. This is y is equal to x to the power of 2 over x. So that 2 over x is your exponent. You can't derive that the way it's written. Take the ln of both sides, bring that exponent down. Follow my pattern from what I did before. And then send me your answer. Okay, and here's your homework. Don't try to rush through it. Remember, stay organized, identify your A's and your U's, keep everything nice, neat, and tidy, and you're going to be just fine.